Marika, pour cette belle présentation. On était en orbite avec toi. Et maintenant, Marika Branchesi, qui est donc été classée par la revue Nature comme une des 10 personnalités les plus influentes de la planète. Elle est spécialiste des ondes gravitationnelles et elle nous racontera cette nouvelle manière d'explorer l'univers que Léonard aurait aimé. Merci Marika. Donc, Marika arrive de l'Institut des sciences du Gran Sasso, l'Aquila, l'aigle, pas l'aigle qui atterrit sur la Lune, mais aussi un grand engagement de la part de la science citoyenne de créer un institut pour la recherche après les tremblements de terre en Italie. Merci Marika.
Bonjour, buongiorno. I am really very honored to be here. Grazie, merci. This is the moon. This is our moon, and attracted the attention of Leonardo. Leonardo was a scientist, was an artist, was an inventor, was an engineer. He was driven by curiosity, by intuition, and a lot of passion for work. And these are also what the same spirits that brought us to open a new way to explore the universe, and in particular to study this type of object. I am sure that all of you saw these images in the newspaper. This is a black hole. This is a huge black hole at the center of a galaxy that is not very distant from us. This is 1,000 of billion mass of sun. These are gigantic black holes at the center of the galaxy. And this new way to explore the universe allowed us to understand better this type of object. Not so big. The one that we are now able to observe are a few times the sun. And we don't know nothing about the relation about this huge black hole at the center of the galaxy and the black hole that I will talk you today. So, gravitational waves were predicted by Einstein exactly 100 years ago. And a new way to observe the universe through gravitational waves was opened a few years ago. And they are ripples in the space-time that propagate at the speed of light. And now I let you listen the first gravitational wave observed in Earth. This was an extremely short signal, fraction of a second, but told us a long story. And this tells us the story of two black holes spiraling one around the other, emitting gravitational waves, and they merge together in a more massive black hole. These are about 30 solar mass black holes. In the moment of the merger, the power emitted in gravitational wave was higher than all the power of the star in the observable universe. The gravitational waves start to propagate and cross thousands of galaxies and arrive to Earth the 14th of September 2015. And we were able to detect this sound. Today, we detect this type of sound every week to week. This discovery brought to the Nobel Prize to Ray Weiss, Barry Barish, and Kip Thorne. And I want to add other two, I think, key people that are Adalberto Giazzotto and Alain Brier. All these people were visionary scientists. They dreamed the detection of gravitational waves. They worked for 40 years, and now thanks to these people and to many other people, we can now observe what before was invisible through gravitational waves. When there is a gravitational wave signal, we want not only to look at the gravitational waves, but also to look at the light, because in this way we can have a complete picture of the astrophysical sources that emit gravitational waves. And so all the time we try also to point all the telescope and all the satellite to catch the light. For all the binary black hole that collide, we had no light. And this is also what we expected, because nothing escaped from the black hole, and around the black hole there is not enough material to give rise to light. But we had another big discovery, the 17th of August 2017. Can you try to open the video? I want to let you listen to another type of sound. Okay. So this was a longer signal, about 1 minute, and then a satellite, Fermi, and then another satellite, Integral, detected 1.7 seconds after the gravitational waves a gamma ray burst, a flash in the gamma ray. So we have in front of you our dream, so a gravitational waves coming from a different object, neutron star, and the light in the gamma. So the signal comes from the merger of two neutron stars. Neutron stars are very exotic stars. About 2 suns in 20 kilometers. We saw the merger, the dancing of these two neutron stars, one around the other, and they were destroyed, part of them, and this gave rise to 2 jets propagating at the speed of light, and also other material all around. And we expected not only the gamma ray emission, but also the light in the visible light, so from the ultraviolet, visible light, and infrared light. So now I show you the position in the sky of this signal. So this is the blue line here are the sky localization of this signal from the gravitational waves. So this signal was pretty close, not like the black hole, 1.2 billion of years. This one was 130 million of years. In a volume of the universe where we know the galaxy, there were 50 galaxies to be observed. The Chilean telescope started to observe each of these galaxies, and in one of them they discovered a light, a new light that was not there before. This galaxy became extremely famous, is NGC 4993. This is the object that we discovered, an object that at the beginning was blue, and in 10 days it became red. And this was the light from the merger of these 2 neutron stars. I show you the same object. This is the object that declined its temperature very rapidly, that from blue becomes red. And you can see here this wave. These are a spectra, brightness versus wavelength. And these waves, this structure that you see here, are very important because explain us how all these elements form. So this was a long-standing mystery because we didn't know how the heavy element, heavier than iron, form. And this merger shows us that this is one of the major channels of formation of heavy elements. At the end of the rainbow, so with all the light, we were able also to discover the gold, because among these elements there was also gold. And on the basis of the brightness, we estimate that about 10-100 earth of gold were produced. This gold go in the interstellar mediums, and from this interstellar medium you have new planet new stars. And so the gold that we have in Earth comes from this type of merger in our galaxy. And we are stardust because if we look to the universe, we can find all the elements that are in our body. So studying the universe, we can understand also ourselves and all the things that are around us. And I think that the researcher today, like in the past, Leonardo, make this work because they are driven by curiosity. The curiosity to understand the universe and the curiosity to understand ourselves. So it is not like in the past now that there is only one single scientist. But now the big discoveries, like this one of gravitational waves, comes from many, many scientists that work together with their diversity. For example, this discovery was done by 3,500 scientists, female, male, engineering, astronomer, physicists, all together. Everyone gave a big contribution to this discovery. And another thing that I want to show you is these last images. That is, I don't know if you can see the very small point there in the line. This small point is Earth observed by the universe. And we are really very small in the universe, but Earth is what makes us alive. It's what gives us the life. And I think that we need to protect Earth. And from here, we observe the sky with the same curiosity of Leonardo.